Okay, we're going to graph this. The first step to graphing this equation is to find the x and y intercepts. To find the y-intercept, you plug 0 for x. When we do that, we get 0. To find the x-intercept, you plug 0 for y. And when you solve it, you just set the top equal to 0, the bottom not for this situation. You don't set equal to 0. So when I set the top equal to 0, you get 0. So your x and y intercept is 0, 0. It's both your x and your y intercept. Next, we look for vertical asymptotes, and you do that by setting the denominator equal to 0. When you solve this, you can't. You get imaginary, so there aren't any. Next, you have to find critical numbers, so you take the derivative of this, break it down, breaks down some more to this. Then you set the top and bottom equal to 0. So the top and bottom equal to 0. This is imaginary. There are no solutions. We talked about that here. The top equals 0. So you have a critical number at 0. Then we want to find horizontal asymptotes. How you find horizontal asymptotes is you divide everything by the highest degree in the denominator. So we're going to divide everything by x squared. See, x squared, x squared, x squared. When you do that, you end up with, this just ends up with 2. That ends up with 1. And that ends up with 4x squared. Then where did I get 2 from? When you plug infinity in, 4 over infinity squared is 0. 2 over 1 is 2. So as x approaches infinity, you get 2. Now, if you plugged in negative infinity, you would also get 2. So you also want to plug in negative infinity to make sure the negative infinity side is the same value output. Then you make this table because your critical number is your breakpoint. So 0 is your breakpoint, and you go from negative infinity to 0 and 0 to infinity, because critical numbers are where you have relative maxes and mins. Then I plug the value on either side. I plug in -1 for this interval and 1 for this interval into the derivative. This came out to be negative, this came out to be positive. So if it's decreasing and then it's increasing, that means it's a little smile, so it is a minimum at 0, 0. Now I could find points of inflections, but the question does not ask for that. Now I'm going to sketch it. Now if the sketch is going to go up against this asymptote, but then go down to here, because it's decreasing on the whole interval, this is what it would probably look like, something like this. And for this one, it's increasing, and it's going to go up to this asymptote, so it probably looks something like that. 0, 0 is right there. So that's probably what it's going to look like. Now, going back up here to find the critical numbers, when you are making your derivative like this, one thing you want to be careful of, when you get to here, try to pull out your GCFs. It makes life a lot easier. And what you notice is both these have a 4x in common. When you break this down, you get just basically, it looks like a 4x, just 4. And when you multiply the 4 times the 4x, you get 16x. That makes it a little bit easier than trying to FOIL and do all sorts of junk. But remember, for critical numbers, you set the top and bottom equal to 0. Make sure you look for vertical and horizontal asymptotes. Make your little table to find out how the intervals are working and to see if it's actually relative max or relative min.